Hi, I'm Rityunjay. This is Transformer Telemetry, a lightweight terminal UI that hooks into llama.cpp to give you real-time visibility into what's happening inside the transformer model during inference. Let me show you how it works. I am running PHI 3 mini locally. As the model generates tokens, the tool is hooking onto every layer of the transformer in real time. On the left, panel 1 shows every token for the model generated. Here that prints all the other tokens generated. Each one expands into a 32 layer capture because PHI 3 has 32 transformer layers. Pressing enter drills into the tokens layers. Here I can see that latency for each one of the 32 layers. First one has 23 milliseconds, second one has 27 milliseconds, and so on. Panel 3 shows runtime matrix for whichever layer is selected. The tensor shape, exact latency, and sparsity percentage. Panel 4 is the real attention matrix. These block character represent the actual softmax attention weights computed during inference. You can see the casual masking pattern. Each token only attends to itself and the previous token, which is exactly how a decoder only model should behave. Uh, Tab focus between panels and JK navigates in whichever one is active, similar to Vim. Once inference is completed, panel 5 computes an anomaly report. It averages latency and sparsity across all tokens per layer and flags any layer that's significantly slower or sparser than the mean. Here you can see none of the layer is actually flagged. Let me explain how this actually works. There is no database or API here. This is a local single process tool that directly talks to the llama CPP's API. So instead of API endpoints, the key integration point is the callback function. Llama.cpp exposes a hook called cbeval. It fires after every single tensor operation inside the model's forward pass. I registered this callback before creating the inference context. This section is the entire integration. Here, every time the model computes anything, my function gets called within the pointer to that tensor. Inside the callback, I filtered two tensor output. L underscore out, which is the final output of the each transformation, and KQ softmax, which is the entire weight matrix. Everything else gets skipped. Captured data goes into a fixed size ring buffer, 512 slots, protected by a mutex. This matters because the inference runs on one thread and the UI renders on another. The ring buffer is the safe handoff point between them. The UI itself is built with FXTUI, a CPP library for terminal interfaces. It read renders every zero point 0.2 seconds, reading whatever is currently in the ring buffer and the token history. To verify this is actually reading real model internals and not just simulating data, I am gonna run this again with another different prompt. If you navigate between different layers, the attention matrix changes. This is because reading real KQ softmax tensor data from each layer's computation, not hard-coded values. Running on different prompt produces a different token sequence and a different latency numbers each time. This is transformer telemetry, a non-invasive way to see inside a running transformer model built entirely in C++ on top of llama.cpp and fxty. Code is on GitHub. Thanks for watching.